Hi, today we are going to discuss topic 9, quantization of light. We will discuss three things, namely, A. State Planck's quantum theory. B. Distinguish between Planck's quantum theory and classical theory of energy. C. Use Einstein's equation for a photon energy. According to Planck's quantum theory, different atoms and molecules can emit or absorb energy in discrete quantities only. The smallest amount of energy that can be emitted or absorbed in the form of electromagnetic radiation is known as quantum. The foundation of Planck's quantum theory is a theory of blackbody radiation. The Planck's quantum theory explains the observations in the blackbody radiation.
A blackbody is an idealized physical body that absorbs all incident electromagnetic radiation, regardless of frequency or angle of incidence. The name blackbody is given because it absorbs radiation in all frequencies, not because it only absorbs. A blackbody can emit blackbody radiation. The electromagnetic radiation emitted by the blackbody is called blackbody radiation. The best practical blackbody is a small hole in a box with a blackened interior, because practically none of the radiation entering such a hole could escape again, and it would be absorbed inside. A surface covered with lampblack will absorb about 97% of the incident light and, for most purposes, can be considered a blackbody. Polished metal surfaces, on the other hand, absorb only about 6% of the incident radiation, reflecting the rest. As light enters the cavity through the small hole, part is reflected and part is absorbed on each reflection from the interior walls. After any reflections, essentially all the incident energy is absorbed.
Assumptions made by Planck. 1. The electromagnetic M radiation emitted or absorbed by the blackbody not in a continuous stream of waves but in discrete little bundles, separate packets of energy or quanta, known as photon. 2. This means the energy of M radiation is quantized. Not all values of energy are possible. 3. The energy size of the radiation depends on its frequency. Classical physics of blackbody radiation, Rayleigh, Jean law. 1. Classical physics predicts a blackbody radiation curve that rises without limit as the frequency increases. 2. An object at any temperature emits radiation, energy. 3. Energy of the M radiation is continuously. 4. Energy of the M radiation is related to the amplitude and does not depend on its frequency or wavelength.
5. The blackbody spectrum depends only on the temperature of the object, and not on what it is made of. An iron horseshoe, a ceramic vase, and a piece of charcoal, all emit the same blackbody spectrum if their temperatures are the same. 6. As the temperature of an object increases, it emits more blackbody energy at all wavelengths. As the temperature of an object increases, the peak wavelength of the blackbody spectrum becomes shorter, bluer. For example, blue stars are hotter than red stars. The blackbody spectrum always becomes small at the left-hand side, the short wavelength, high-frequency side. From this graph, idea of classical theory only fit for longer wavelength but failed to explain the curve for lower wavelength. The photoelectric effect could not be rationalized based on existing theories of light, as an increase in the intensity of light did not lead to the same outcome as an increase in the energy of the light. People were confused that an increase in the energy of light was the same as the increase in its intensity. Planck postulated that the energy of light is proportional to the frequency, and the constant that relates them is known as Planck's constant, h. His work led to Albert Einstein determining that light exists in discrete quanta of energy, or photons. These photons are responsible for the photoelectric effects in quantum physics as well as atomic structure of chemistry. Photons are referred to packets or bundles of energy. Planck stated that the light energy is directly proportional to the frequency of the light wave. 9.1b. Distinguish between Planck quantum theory and classical theory of energy. Planck's quantum theory. 1. Energy of the M radiation is quantized, discrete. 2. Energy of M radiation depends on its frequency or wavelength. Classical theory. 1. Energy of the M radiation is continuously. 2. Energy of the M radiation depends on intensity, does not depend on its frequency.
What is photon? Please memorize this definition. Photon is defined as a particle with zero mass consisting of a quantum of electromagnetic radiation, where its energy is concentrated. This is important. From the equation, we know that 1. Photon energy is directly proportional with frequency of M radiation. 2. Photon energy is inversely proportional with wavelength of M radiation. What is unit of photon? Unit of photon energy is joule, or electron volt. Please memorize this definition. The electron volt, eV, is a unit of energy that can be defined as the kinetic energy gained by an electron in being accelerated by a potential difference, voltage, of 1 volt. We need to know that photons travel at the speed of light in a vacuum. This is important. For unit conversion, 1 electron volt is equal to 1.60 times 10 power of -19 joule. Photons are required to explain the photoelectric effect and other phenomena that require light to have particle property. That's all for subtopic 9.1. Thank you. See you again in the tutorial class.